It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
Where you put your knowledge to test
and battle it out with the best.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
with detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now.
Yes, hello students. Welcome to the session. Welcome to Unacademy Telugu channel. Students, before starting today's concept, let me introduce myself. Yes, my name is Surendra Babu. For 10 years, I am educating the students for GATE, ESE and PSUs in the field of electrical and electronics engineering. Students, these are the subjects I am teaching for GATE, ESE and PSUs, that is power electronics, power systems, electrical machines, electrical and electronic measurements. And this subject I am teaching for instrumentation students, that is transducers and mechanical instrumentation. Students, apply my promo code BABU10, get the 10% discount on Unacademy Plus subscription. This about me. Yes, students, come to our Unacademy subscriptions. There is a plus subscription. If you select the plus subscription, these are the benefits you can get the students. Live classes, crash courses, weekly tests, doubt solving sessions, that is available in English and Hindi. And there is a one more subscription, student, that is iconic subscription. If you select the iconic subscription, these are the benefits you can get. These extra benefits along with plus subscription, these extra benefits are added to the, that is personal coach is available, study planner, study booster sessions, personalized test analysis, preparatory study material. These extra benefits are added for plus subscription students. If you select the iconic subscription, you please concentrate. Sir, how to get our Unacademy learning app, sir? Then search our Unacademy learning app in Play Store. Then install. This is the second step. Students, the third step is manage your goals. Select your goal. Now you are in GATE and ESE. Then select the GATE and ESE. Then select plus. Get the subscription. Student, these are the steps you follow to get the Unacademy learning app subscription. Now see what are the course fee details for plus subscription. For GATE and ESE, for 1 year program, for 12 months, that is 1 year program. For plus subscription, apply my promo code BABU10, get the 10% discount and you pay only 27,225 rupees, students. This also for GATE and ESE, for plus subscription, for 18 months program. This is a 1.5 year program, students. Apply my promo code BABU10, then get the 10% discount. Then after that you pay only 34,650 rupees. Yeah, this also for plus subscription for GATE and ESE. It's for 24 months program, students. That is a 2-year program. Apply my promo code BABU10, get the 10% discount. Then you pay only 39,600 rupees, students. Yes. Now come to the iconic subscription, students. For 12 months program, apply my promo code BABU10, get the 10% discount and you pay only 45,225 rupees. Yeah, this also for iconic subscription, students. That is for 24 months program. That is a 2-year program, students. Then apply my promo code BABU10, get the 10% discount. Then you pay only 66,600 rupees. This is about course fee details for plus subscription and iconic subscription. You please concentrate. Students, these are our top educators who is taking the classes in plus batches. These are the batches are going on plus batches. That is the target ESE prelims for 2021. That is electrical. Rank booster batch for GATE 2021. That is for ECE. Target ESE prelims for 2021. That is for electrical. Rank booster batch for GATE 2021 for batch B. That is for electrical. You please concentrate. These are our top educator faculty that for electrical and ECE. This is our Unacademy GATE Telugu December month schedule and crash course schedule, students. In December month schedule, along with the timings also it is mentioned. You please follow all these subjects. That is communication system, electrical machines, engineering mathematics, power systems, aptitude. For crash courses, this is power electronics, EDC and aptitude, students. You please concentrate. Students, good evening all. Now come to the today concept. I am going to discuss most expected questions for GATE, ESE and PSUs from the symmetrical components. That is both from symmetrical component sequence networks. What are the questions we can expect? That questions I want to discuss. Already in the previous sessions, I given practice questions and I given some GATE, ESE and PSUs questions also I already solved. Now you see the some most expected questions for GATE, ESE and PSUs based on symmetrical components and the sequence network, students. Okay, students, shall we start? We'll see the first question. I'm reading the question first. A three-phase 4-wire transmission line has positive and zero sequence impedances J10 ohms and J30 ohms respectively. The neutral impedance is J2 ohms. No mutual linkages exist between phase wire to neutral. That means here there is no any mutual linkage between this wire to the neutral, this wire to the neutral, this wire to the neutral. That condition is given, students. Okay, then with this you find the what is the self impedance of the each phase. That means you want to find the what is the ZS, students. What here it is given? Positive sequence impedance is given. You know what is the positive sequence impedance? ZS minus ZM. And zero sequence impedance is given, students. What is Z0 equal to ZS plus 2ZM. But along with the neutral impedance is given. That's why you take 3ZM. This formula already given in the concept, students. Then from this, by solving these two equations, you want to find what is the self impedance of each phase. That means you want to find the ZS, students. Yes, you concentrate. What is the solution for this one? Here I am giving the solution. You please concentrate. Yes, students. What is the positive sequence impedance is given? Z1 equal to ZS minus ZM. ZS minus ZM. This how much positive sequence impedance is given, students? That is a J10. Yes, sir, you concentrate. Z1 equal to J10 ohms, sir. Then what is the zero sequence impedance, sir? Zero sequence impedance equal to ZS plus 2ZM plus 3ZN. 3ZN equal to how much it is given? J30 ohms, sir. It is given J30 ohms. You concentrate. Okay, but what is the ZN is given? The neutral impedance is given, students. The neutral impedance equal to J2 ohms. It is given as J2 ohms. Now you substitute neutral impedance here. You can get what is the ZS plus 2ZM. Then ZS plus 2ZM equal to J30 minus 2. That is 3ZN, students. What is the ZN? J2. Then J30 minus, you substitute ZN here. J2 into 3, J6 we can get. Then how much, students? J24, 24 ohms. J24 ohms. Now you want to solve ZS and these two equations. This ZS plus 2ZM, ZS minus ZM equations you solve, students. Then what you get? ZS plus 2ZM equal to J24 ohms, sir. What is the ZS minus ZM, sir? ZS minus ZM equal to J10 ohms, sir. Yes, first I will calculate what is the ZM. Then you subtract this one. You subtract this, minus becomes plus. What is the 3ZM, students? This 3Zm equal to J34. Sir, you are subtracting now. You please concentrate. Yeah, this how much? J14 ohms. Okay, what is the Zm, students? The mutual impedance. The mutual impedance Zm equal to, that is J14 by 3 ohms. Okay, this Zm. But you want which one? You want Zs. Take any one equation here, any relation. We know that Zs minus Zm equal to J10 ohms, students. Then what is the Zs, sir? J10 plus. J10 plus. What is Zm, sir? J14 by 3. Then how much Zs we can get, sir? This Zs equal to, this is J30 plus 14, J44 by 3. Then what the 44 by 3, sir, we can get? Then how much Zs we can get? This Zs equal, by simplifying that, we can get, this is 14.66, students. 14.66 ohms. This is the self impedance. The self impedance of each phase is 14.66 ohms. That you concentrate. Clear? This here extra, I am giving this problem by giving the neutral impedance also. By giving the neutral impedance also. Sir, one observation, sir. Yeah, this problem is over. No doubt at all. This problem is completed. Zs equal to J14.66 ohms, sir. J14 point. That means what the self impedance of each phase? This is the answer, sir. The self impedance of each phase is J14.66 ohms. Yes, sir. This is the answer. This is a solution for this problem. Yes, but here I want to give one note, student. This observation you remember. Sir, what is the Z1 equal to Z2 equal to in transmission line, sir? Zs minus Zm, sir. Yes, sir. What about Z0 equal to, sir? Z0 equal to Zs plus 2Zm plus, if neutral impedance is also given, 3Zm, sir. Okay, this is the Z0, sir. Now, if the question is asked like this, students, if the question is asked like this, in the case of transmission line, at what condition Z1 equal to Z2 equal to Z0? But here actually in transmission lines Z1 equal to Z2, but Z0 is greater than the as compared to Z1 and Z2. But the actual condition that one. But now I am asking the condition. At what condition this Z1 equal to Z2 equal to Z0? If the question asked like this, then what is your answer, students? When this Z1 equal to Z2 equal to Z0, student, in transmission line, if there is no any mutual impedance effect, then there is no any neutral impedance effect, students. If these two are 0, then only Z1 equal to Z2 equal to Z0. This is equal to Zs, students. Yeah, this is the condition. If any condition is asked, you ready to write the answer. Okay, not asked, but we can expect like this also. Here Z1 equal Z2 equal Zs minus Zm, student. Z0 equal to Zs plus 2Zm plus 3Zm. Now at what condition these all the impedances are equal? To substitute Zm equal to 0, Zn equal to 0 here. If Zm equal to 0 here, Zs. If Zm and Zn also 0 here, Zs. Then only Z1 equal to Z2 equal to Z0 equal to Zs. Along with this problem, this condition also you remember, students. If any question is asked, you ready to answer. Is it okay? Understood? You please concentrate. Yes, very important questions I am solving here. Please inform to your friends, students. Okay, all of you, you please concentrate. Yes. Now see the question number 2. Yes, students, you please concentrate. In a three-phase unbalanced system, the receiving end line voltages of transmission lines are VAB equal to 100 at angle of 0 degrees, VAC equal to 80 at angle of minus 90 degree volts. Then find the positive sequence component of VAB. Students, you want to find what is the positive sequence component of VAB. What is VAB is given? VAB equal to 100 at angle of 0 degrees, students. 100 at angle of 0 degrees. What is VAC, sir? VAC equal to 80 at angle of minus 90 degrees, sir. 80 at angle of minus 90 degrees. Then what you want to find, sir? VAB1. Positive sequence component of VAB you want to find. VAB1. Sir, can you tell what the formula for VAB1, sir? VAB1 equal to 1 by 3 as VAB plus alpha into VA, this VA alpha into VBC plus alpha square into VCA students. Here this is the formula for VAB1. That is the positive sequence component of VAB1. VAB. That is 1 by 3 into VAB plus alpha into VBC plus alpha square into VCA students. This formula you know. Now, but here VAC is given, but I want to find VCA students. Here I want to find VCA. But what about VBC? VBC you don't know. Here VBC is not given. Then you also write this VBC in terms of VAB and VCA. In terms of VAB and VCA. Yes, you will see the continuation of this. Students, concentrate. What is VAB given, sir? VAB equal to how much it is given, sir? 100 at angle of 0 degrees, sir. Yes, you please concentrate. How much VBC given, sir? VBC. Is it VBC is given? Yes. VBC, sir. VBC is not given. VBC is not given. You please concentrate. Yes. VBC is not given, sir. It is given is VAC. VAC given. Is correct? VAC is how much? 80 at angle of minus 9. 80 at angle of minus 90, sir. VAC is 80 at angle of minus 90. Yes. This is given as 80 at angle of minus 90, sir. Is correct? 80 at angle of minus 90. Yes, sir. This is VAC. But I want VCA, sir. VAC. But I want VCA. What is VCA, sir? This VCA equal to minus 80 at angle of minus 90. If VAC is 80 at angle of minus 90, VCA equal to minus of that one, sir. Then minus 80 at angle of minus 90. Shall we write like this, sir? This minus I am writing as a 1 at angle of 180. This minus I am writing as a 1 at angle of 180. This minus 1 you can write 1 at angle of 180, sir. This you know. Then 1 at angle of 180. This I am writing as a at angle of minus 90, sir. Into 80. Okay. This is this 80 at angle of 90 degrees you write. That means minus 80 at angle of minus 80 at angle of minus 90 equal to 80 at angle of plus 90, sir. This is equal. Now, given that line voltages, sir, in the line to line voltages, all the zero sequence, there is no any zero sequence components. In line to line voltages, there is no any zero sequence components. There is no any zero sequence component. There is no any zero sequence components, sir. Is correct? When there is no any zero sequence component means VAB plus VBC plus VCA equal to 0, sir. If VAB plus VBC plus VCA equal to 0 means, then how we can write? I want VBC, sir. What is VBC, sir? Minus VAB minus VCA. Yes. Then what is VAB1 formula, sir? This VAB1 equal to 1 by 3 into VAB plus alpha into VBC plus alpha square into VCA students. You please concentrate. 1 by 3 into VAB plus alpha into, replace VBC by minus VAB minus VCA, sir, plus alpha square into VCA, sir. So, okay, alpha square into VCA. Now tell me, students, what is VAB1, sir? VAB1 equal to 1 by 3 into, I am taking VAB is common, sir, 1 minus alpha. Next, I am taking VCA common, sir. VCA is common. Alpha square minus 1, sir. Alpha square minus 1. Now you substitute, sir. 1 by 3 into, what is VAB, sir? 100 at angle of 0 degrees, sir. But you know this value of 1 minus alpha, sir. 1 minus alpha is already given in the phase shift operator characteristics. Root 3 at angle of minus 30 degrees, sir. Root 3 at angle of minus 30 degrees. What is VCA, sir? 80 at angle of 90 degrees, sir. What is alpha square minus 1, sir? This formula also you know, alpha square minus 1 value is root 3 at angle of minus 90 degrees. This you simplify, then positive component of line voltage we can get 100.42 at angle of minus 16.70. Okay, this is the VAB1. Then finally I am giving sir, this is 16. Then what is VAB1 sir? The value of VAB1 equal to 100.42 at angle of minus 16.70. Okay, this is the calculations. You place this condition, you substitute here, then you can get the what is the positive sequence component of line voltage. In line voltages, you don't have any zero sequence component. Using that one, I written this VBC in terms of VAB and VCA, sir. But actually here VAC is given, sir. This is VAC. VAC, sir. I written VCA. VAC means what? What is this one, sir? VA minus VC, sir. What is VCA, sir? VC minus VA, sir, in a vector notation. But I want VCA means VA minus VC. Negative of VA minus VC, sir. This negative of VA minus VC. That is what is VA minus VC, sir? VAC. That's why I taken VCA equal to minus VAC, sir. This is minus VAC. That's why I taken like this. Okay. Now this minus 1, this minus I written as 1 at angle of 180, sir. That minus at angle of 90. This magnitude is 80 is there, sir. Then 80 at angle of 90 degrees. This I substituted. 80 at angle of 90 degrees, sir. Alpha square minus 1 value is root 3 at angle of minus 90 degrees, sir. Then all this you simplify, we can get 100.42 at angle of minus 16.70. Okay, sir. Students, you please concentrate. This is the question number 2. It's a very simple question. Just we are applying the formulas. Yes, sir. You see the question number 3. You please concentrate. Yes, students, read the question. Yes. The line to ground voltages on the high voltage side of a step-up transformer are line to ground voltage means phase voltages, students. Here phase voltages are given. 100 kV, 33 kV and 38 kV on phases A, B and C respectively. This A phase voltage, B phase voltage, C phase voltage are given, students. The voltage of phase A leads that of phase B by 100 degrees. Yeah, you please concentrate. The voltage of phase A leads that of phase B. That means phase A leads phase B. That means phase B is lagging, students. Understand? This phase A leads phase B. Leads phase, vector rotation is anti-clock. Phase A leads phase B, students. That means phase B is lagging. Then what is phase B is lagging? That is 100 degrees. Phase B is lagging by 100 degrees. And lags that of phase C by 176.5 degrees. The voltage of phase A leads that of phase B by 100 degrees and that lags that of phase C by 176.5. That means phase A lagging with respect to phase C. Okay. Now see, the voltage of phase A. First I am writing the students what is VA. This VA is 100 at angle of 0 degrees. VA equal to 100 at angle of 0 degrees. Now what is VB, students? VB equal to this amplitude, the magnitude is 33. All these are in kV. 33 at angle of, but our reference is A phase, students. Now B is lagging with A by how many degrees? 100 degrees. This is given as 100 degrees. What about C? V phase. VC equal to, then how much magnitude is given? 38. 38, but it is leading. What it is given? This VC. VA lags. This one, see the students. The phase voltage. The voltage of phase A leads that of phase B by 100 degrees. That is correct. But phase A lags. Phase A lags with respect to C. Means phase C leads. Phase C leads. Phase C leads with respect to A. This is how many degrees, students? It is given 176.5 degrees. 176.5 degrees. Okay. This is the voltages. Phase A, phase B is lagging with phase A. That's why I taken minus. phase C is leading with phase A. Why? Phase A is lagging with phase C means phase C is leading with phase A. Leading, that's why taken plus 176.5 degrees students. Now what you want to calculate? Determine analytically the symmetrical components of voltages. Then you want to find what is the symmetrical component of that. You take what is the symmetrical voltages you want to find. Mainly concentrate VA0, VA1, VA2. That is enough. Yeah, what is VA0 students? VA0 equal to 1 by 3 into, yes, 1 by 3 into VA plus VB plus VC, sir. VA plus VB plus VC. Then what is VA0 equal to 1 by 3 into, what is VA, sir? 100 at angle of 0 degrees plus, what is VB, sir? 33 at angle of minus 100 plus, what is VC, sir? 38 at angle of 176.5 degrees, sir. Then you simplify this, sir. How much VA0 you can get? This VA0 equal to 18.79. 18.79 minus J 10.06. Students, use a calculator. You solve this one. This is in terms of kV, sir. All it is given in kV. All these voltages are in kV, sir. Okay, that's why this A phase symmetrical zero sequence component is 18.79 minus J 10.06 kV, sir. Is okay? That is a VA0 is over. Okay, this is the calculation of VA0, sir. Okay. Now let's see the students. What is VA1, sir? VA1 I am writing. VA1 equal to 1 by 3 into VA plus alpha into VB plus alpha square into VC, sir. That is 1 by 3 into how much VA, sir? VA is 100 at angle of 0 degrees, sir. Plus alpha means 1 at angle of 120, sir. How much VB, sir? VB is 33 at angle of minus 100, sir. At angle of minus 100 degrees, sir. Yeah, this is VB, sir. Then alpha square means 1 at angle of 240, sir. Into what is VC, sir? VC is how much it is given? 38 into 176.5 degrees, sir. Okay, this you simplify, sir. How much VA1 you can get? The positive sequence component voltage is 50.65 plus J 14.32 kV. J 14.32 kV. That you concentrate. Next you concentrate VA2, sir. VA2 equal what the formula? 1 by 3 into VA plus alpha square into VB plus alpha into VC, sir. All these values you know, sir. That you substitute, sir. That is 1 by 3 into, that is 100 at angle of 0 degrees. Yes, 100 at angle of 0 degrees. That is 1 at angle of 240 into, what is VB, sir? 33 at angle of minus 100 plus alpha is how much, sir? 1 at angle of 120. Alpha VC is how much, sir? VC is how much? 38 at angle of 176.5 degrees. Then you simplify this, sir. What is VA2 we can get? VA2 we can get 30.55 minus J 4.26 kV. You please, if any corrections with respect to calculations you do, sir. That is in our hand. Okay. 30, all are having the calculators. You do this one. 30.55 minus J 4.26 kV, sir. This is VA0, VA1 and VA2. These are the sequence components. Here in this problem, this what is the variety in this problem is, based on this you decide the angles, sir. Data is given, according to that you write the angles, then you can substitute. If you take minus plus change, then you can get the wrong answer. You please concentrate, sir. Phase A is leading means phase B is lagging, sir. Phase C is lagging with respect to, phase A is lagging with respect to phase C means phase C is leading, sir. That's why taken this is plus and this is the minus, sir. So, okay students, please concentrate. This is about question number 3. Yes sir, you concentrate on question number 4. Yes sir. What is the solution for this problem? You first read the question. In a three-phase unbalanced system, symmetrical component of voltage at a bus bar are given as V1 0.9, V2 minus 0.3, V0 minus 0.1 per unit, sir. That means this is the positive sequence component, sir. This is VA1. Yeah, this is VA2. Okay, this is VA0, sir. The positive sequence component is 0.9 per unit. This is negative sequence is minus 0.3 per unit. The zero sequence component is minus 0.1 per unit, sir. Then find VA in per unit, find VAB in per unit. That means you want to find the per unit phase voltage, per unit line voltage. Both you want to find. Yes, sir. What is VA, sir? This VA equal to VA0 plus VA1 plus VA2, sir. So, okay, VA0 plus VA1 plus VA2, sir. How much VA0 is given, sir? Minus 0.1, sir. How much VA2 is given, sir? Minus 0.3. VA2 is minus 0.3. How much? Yes, VA1 is 0.9, sir. I am substituting VA1. VA1 is 0.9. VA2 is minus 0.3, sir. Then you simplify this, how much you can get, sir? 0.5 per unit. That is, we find VA in per unit is 0.5 per unit. Now you want to find VAB. Sir, how to get VAB? This VAB equal to VA minus VB, sir. VAB equal to VA minus VB. But first you want to find VB, sir. How to find VB, sir? VB equal to, you know the formula. VA naught plus VB equal to alpha square into VA1 plus alpha into VA2, sir. Alpha into VA2. Then what is VB, sir? VA naught is how much? VA naught is minus 0.1, sir. VA naught is minus 0.1. What is alpha square, sir? 1 at angle of 240 into what is VA1, sir? That is 0.9 plus this is a minus I am giving or 1 at angle of 120. This is how much, sir? VA2. VA2 is minus 0.3, sir. Then you substitute this, simplify this, sir. How much VB you can get, the students? You please concentrate. How much VB you can get? You simplify this one. 1.16 at angle of minus 111.04, sir. Minus 111.04 degrees we can get. Now what is VAB, sir? VAB equal to VA minus VB. VA is 0.5, sir. VB is 1.16, sir. At angle of minus 111.04, sir. Then you simplify this. How much VAB we can get? 1.37. This is 1.37 at angle of 49 degrees we can get. At angle of 49 degrees. Therefore, VAB, how much VAB, sir? VAB per unit equal to 1.37 per unit. If you take only magnitude, then your answer is 1.37 per unit. Understand? Like this, we calculate VA per unit, VAB per unit. Students, please concentrate. Very important model. If it is asked VA per unit, how to calculate VAB per unit? VAB per unit equal to VA minus VB. Is okay? Then we are getting 1.37 per unit. Clear, students? Yes, concentrate. Yeah, this is a question number 4, sir. Now see the question number 5. Yes, students, concentrate. Important model. For the following delta connection, find the positive sequence of a line current. For the following delta connection, find the positive sequence of a line current. That means you want to find the what is the IA1, sir. This IA, IB, IC are the line currents, sir. IA, IB and IC are the line currents, sir. What is IA1 formula, sir? Then IA1 equal to 1 by 3 into IA plus this you write alpha into IB plus alpha square into IC, sir. But you know that, sir, in delta connection. But here IA is how much it is given, sir? IA equal to, yes, sir. IA equal to 10 at angle of 30 degrees, sir. 10 at angle of 30 degrees, sir. How much IB is given, sir? IB equal to 15 at angle of minus 30 degrees, sir. 15 at angle of minus 30 degrees. but IC is not given, sir. You want to write IC, sir. But you know that in delta connection, this concept I already explained, sir. In delta connection, in lines, there is no zero sequence currents. There is no zero sequence currents. There is no zero sequence currents. You don't have any zero sequence currents in the lines. Then what the conditions are? IA plus IB plus IC equal to 0, sir. Now you substitute IC as minus of IA plus IB. Okay, sir. Now you write this one. What is IA1, sir? IA1 equal to 1 by 3 times of this IA plus alpha IB plus alpha square. Replace IC as minus of IA plus IB, sir. So okay. Then what is IA1, sir? IA1 equal to 1 by 3 times of. Take IA is common. 1 minus alpha square, sir. Take IB is common. Alpha square. IB is common, sir. Alpha minus alpha square, sir. Now you substitute all these values, sir. What is IA1 equal to 1 by 3? IA is how much? 10 at angle of 30 degrees, sir. What is 1 minus alpha square? That you know. Root 3 at angle of 30 degrees. Yes, is okay. Root 3 at angle of 30 degrees. Plus, what is IB, sir? IB is given 15 at angle of minus 30. What is alpha minus alpha square, sir? Alpha minus alpha square, you know this one. How much? Alpha minus alpha square you can get, sir. This alpha minus alpha square equal to root 3 at angle of 90 degrees. This you know. The value of alpha minus alpha square is root 3 at angle of 90. You know what is 1 minus alpha square? Root 3 at angle of 30 degrees. 1 minus alpha, root 3 at angle of minus 30 degrees. Alpha minus alpha square, root 3 at angle of plus 90. 1 minus alpha square, root 3 at angle of minus 90 degrees. All these you know, sir. Then you simplify this, sir. What you can get? This IA1 equal to, this is 60 degrees, sir. 10 root 3 60 degrees. This also 15 root 3 60 degrees, sir. That is 25 root 3 by 3 at angle of 60 degrees. 25 root 3 by 3 at angle of 60 degrees. That is 14.43. 14.43 at angle of 60 degrees. This is the positive sequence current of line current of delta connections. Yes, this is, yes, IA1 equal to, this IA1, sir, IA1 equal to 14.43 at angle of 60 degrees. Then final answer is this one, sir. What is IA1? 14.43 at angle of 60 degrees. This is the positive sequence current for this given connection, for a delta connection. Yes, sir. You please concentrate. Very simple, but most expected model of this question. Simply, it is giving delta connection. You want to find the what the positive sequence current. You write this IC in terms of IA and IB, sir, then problem is over. Then you are solving the question like this. Okay, students, please concentrate. You please concentrate. Yes, this is our Unacademy combat. You please concentrate. India's largest competition for GATE, challenging questions, and you have the super fast and fun with real-time rankings. Compete with best. Know where you stand among us. All the contest. Detailed video solution by top educators. As students, you please concentrate. Then win the best prizes, amazing prizes by participating in the competition. This is our Unacademy combat competition. This enroll for free enrollment, students. This is a free enrollment and register for December 16 6 p.m. Now you can register for December 16th 6 p.m. This is our Unacademy combat students. Now we'll see the continuation. Question number 6. Yes. Students, please concentrate. It's a very important model. It's very important. You please concentrate. In a three-phase system carrying unbalanced current and unbalanced voltages, the symmetrical component of voltage and currents are given as this is the symmetrical components of voltage and currents. This is the positive sequence component, students. This is the negative sequence. This is the zero sequence component. This is VA1. This is VA2. This is VA0. Okay, VA1, VA2, VA0. This is this I1, I2, I0. This is the positive sequence component, students. The positive sequence component current. This is IA1. This is IA2. This is IA0. 0.5 minus J, 0.5 minus J1, 2 minus J1. Okay. All values are in per unit. If the base values are 200 MVA for three phase, it is given. 11 kV is line to line voltage. Then calculate phase A complex power and three phase complex power in MVA. In per unit and MVA. You calculate both in per unit and first you calculate in per unit, then you multiply with base MVA, then you can get the in MVA, students. Okay, very important model. Here you are calculating the complex power, students. Complex power. Per phase complex power I am calculating and three phase complex power is also calculating. Students, you please concentrate. Now what is the solution for this one? I am calculating per phase complex power. For A phase, I am calculating the complex power for calculate the phase A complex power. Yes, students. Yes, sir. What is the per phase complex power? Per phase complex power. Here I am giving the for A phase, students. For A phase. What is the complex power of A phase? SA I am giving. Then how to write? How to write, sir? The complex power equal to VA into IA conjugate. That you know this formula, complex power, VA into IA conjugate. VA is written as, because here sequence components are given, students. VA0 plus VA1 plus VA2. But the IA is, you write, sir, in sequence component. IA0 plus IA1 plus IA2 conjugate, students, all conjugate. Sir, what is the A phase complex power equal to? SA equal to how much? VA is given, sir. How much? VA0 is given, sir. 0.98. This is 0.98. This is the plus. Sir, this is 0.98. What is VA2 is given, sir? Minus 0.3. VA0 is how much, sir? Minus 0.1 into this is IA0, sir. 2 minus J1. You substitute. IA1, sir. 0.5 minus J1. Sir, IA not 0.5 minus J 0.5. All the values you substitute, sir. All conjugates. Yeah, this how much per phase complex power, sir. See, students, very important model. This 0.98 minus 0.4, sir. How much? 0.58. This 0.58 into this how much, sir? This is 2.53. Is correct? 2.5. That is 3. This how much, sir? Minus J1 minus J2 minus J2 minus J2.5, sir. Whole conjugate. Then how to write, sir? We are calculating the complex power, sir. In order to give the convenient sign based on the load, we are making this conjugate, sir. We are making this conjugate. Okay. Then SA equal to 0.583 minus J 2.5 whole conjugate. Then 0.58 into this how much, sir? 3 plus J 2.5. 3 plus J 2 point. If you take the conjugate, it becomes minus, becomes plus, sir. Then what is the A phase complex power, sir? A phase complex power 1.74 plus J 1.45 per unit, sir. Then you want, this is SA in per unit, sir. This is the A phase complex power in per unit. But I want in MVA, sir. If you want to find MVA means 1.74 plus J 1.45 into, you divide with, sir. You divide with per phase power, sir. Per phase. But given MVA rating is how much, sir? This is for three phase, sir. 200. But you want per phase. per phase means 200 because it's a three phase system by 3 sir. Then we can get after multiplying with 200 by 3 sir. After multiplying with 200 by 3, then how much we can get sir? 116 plus 116 plus J 96.6 MVA. This one sir, 96.66 MVA. You multiply with 200 by 3 sir. Why you taken by 3 sir? Because we want to multiply with per phase MVA. Per phase MVA. That is 200. 116 plus J 96.6 MVA. Sir, how to calculate per phase power sir? Please concentrate. Very important model sir. That I substituted VA into IA conjugate sir. What is VA? VA naught plus VA1 plus VA2. What is IA? IA naught plus IA1 plus IA2 whole conjugate sir. You do this one, conjugate of 3 minus J 2.5 sir. We can get 3 plus J 2.5. Then we are getting this 116 plus J 96.6 MVA. Okay sir, this is the per phase. But you want to find the three phase complex power also. Sir, what is the three phase complex power in symmetrical components sir? 3 into this formula you know, VA naught into IA naught conjugate sir. VA1 into IA1 conjugate sir. Plus this formula already derived sir. VA2 into IA2 conjugates. Then what is this sir? 3 into how much VA naught it is given sir? How much VA naught it is given? VA naught is minus 0.1 sir. Minus 0.1. Okay, this VA naught is minus 0.1 sir. You please concentrate. VA naught is minus 0.1. VA2 minus 0.3. This is 0.98 sir. This is 0.98. That I am substituting. Minus 0.1. How much? This is 0.5 minus J 0.5 is given. Plus VA1 is how much sir? 0.98. What is IA1 is given sir? This is 2 minus J1 it is given. 2 minus J1. Plus VA2 how much it is given sir? This one. VA2 is how much? VA2 is how much it is given sir? That is minus 0.3. Minus 0.3. This is minus 0.3. This is 2 minus, this is conjugate sir. Okay. This is VA1. IA1 is how much sir? IA1 is correct. This IA1 is 2 minus J1. But this IA2 is 0.5 minus J1 sir. 0.5 minus J1. Yes, please students concentrate. IA2 is 0.5 minus J1. But it is a whole conjugates. Okay, that you do. Then how much three phase complex power sir? Three phase complex power. 3 into this you simplify minus 0.1 into 0.5 minus plus J 0.5 because it's a conjugate students. Plus J 0.5 plus 0.98 into because it's a conjugate. You write 2 plus J1 students. This conjugate sir. This conjugate 2 minus J1 becomes 2 plus J1. This is minus 0.3 into 0.5 plus J1. 0.5 plus J1. So okay students, you please concentrate. Then you simplify this one. SABC. The three phase complex power equal to 5.28 plus 5.28 plus J 1.89 per unit. 1.89 per unit. Yeah, this is the three phase complex power in per unit. But I want SABC in MVA students. Then what you can get? 5.28 plus J 1.89 into. Then you multiply with per phase power sir. Because here each phase component you already included. That's why you multiply. This is 200 by 3. 200 by 3 MVA. Then after multiplying this one, 373.87. You get 373.87 at angle of 19.69 MVA students. 19.69 MVA. 19.69. This is 19.69 degrees. Please concentrate. Yes, 19.69 MVA. Do you convert this, multiply and convert into polar form, you can get 373.87 MVA. Okay students, yeah, this about how to calculate three phase complex power. Just you substitute the symmetrical components and you take the conjugate. then we can get the three-phase conjugate. Sir, I already discussed why you taken the conjugate in the three-phase. In the fundamentals of three-phase systems, see the special class in our Unacademy special classes. You see in detail nearly 20 minutes, 20 to 25 minutes, 20 minutes nearly. I discussed about why you are taking the conjugates. Here there is some mathematical convention is there, sir. In order to follow that one and based on the load, in order to give the correct sign, we are giving the conjugates, sir. In detail about that, I already discussed in the fundamentals of three-phase power. Sorry, three-phase system. In the fundamentals of three-phase system in our Unacademy special classes. Okay, that you concentrate, sir. You see those videos, then you get idea in detail. Okay, the conjugate is generally in order to give the that is exact sign based on the load. If it is inductive load, then you want to write P plus JQ. If it is a capacitive load, you want to write P minus JQ. In order to give that one, here I am taking the conjugate, sir. But sir, why you take only current conjugate, sir? Why not voltage? Yes, sir. You also take voltage conjugate, sir. But why you are most of the cases our reference is voltage only, sir. Reference is our voltage. Then you take the current is the conjugate, sir. Reference is voltage. Then V conjugate I also you can do, sir. Based on that sign it changes. No doubt at all. But why you are taking the current only, sir? Why not the voltage? But generally you can, our reference is the voltage is the reference. That's why you taking the current is the conjugate, sir. In order to give the correct sign for the based on the load. Okay, correct sign for active power and reactive power. That's why we are giving the conjugate, sir. That you concentrate. 373.87. See, for example, inductive load is there, sir. We want to get P plus JQ, sir. If the capacitive load is there, P minus JQ, sir. In order to get this correct sign, then that's why we are doing the VI conjugate. VI conjugate. I want to get plus JQ. Here I want to get minus JQ, sir. Because the inductor is taking the lag reactive components. Then what about the capacitor? Capacitor is taking the leading reactive component. According to that, you want to give this sign, sir. Okay, if you want to get this sign exactly means, then you take the I conjugate, sir. Okay, that you see in detail. That proof also I given in the fundamentals of three-phase system. I already discussed in the special classes. You follow those classes. Okay. Okay, this is about calculation of per phase complex power and three-phase complex powers. Per phase complex power and three-phase complex power. Understood, students? You please concentrate. Yes, see the one more question, sir. Consider the following single line diagram with all reactance is given in per unit form. Form positive and zero sequence Thevenin's impedances with respect to point A shown in figure. That means you want to find the positive and zero sequence. Negative it is not asked, sir. You want to find only positive and zero sequence Thevenin's impedances with respect to point A, sir. This point A is that middle of the line, sir. Point A is at the middle of the line, sir. That you want to find what the positive sequence impedance and zero sequence impedance, sir. Yes, sir. If you want to find the positive sequence impedance, zero sequence impedance, sir, first you want to draw the sequence network. Yes, students, please concentrate. Yes, sir. First I am drawing the positive sequence network, sir. Positive. So many problems I already solved, but here also I am giving two more problems. Positive sequence network, sir. Students, parallel you practice. Yes, positive sequence. I am drawing the positive sequence. I told already, wherever you are drawing the positive sequence network, sir, there is no that positive sequence network independent of any connection, sir. It's a star or delta, you no need to consider. Directly you can. Here two generators, sir. Generator 1 and generator 2. But in positive sequence network, if there is a generator, you represent along with source, sir. Okay. This is how much positive sequence is given, sir. J.25. J.25. Here there is one more generator, sir. This one more generator. You draw this one, sir. Our reference is neutral, sir, because the network is positive sequence networks. Yes, sir. This also how much, sir? J.25. Next, what it is given, sir? Transformer. How much transformer reactance, positive reactance is given, sir? This positive, negative and zero all are same, it is given, sir. This is how much it is given? J.3 it is given, sir. J.3. Okay, this you concentrate. This is for which transformer? T1, sorry. T1 transformer it is given 0.2 per unit, sir. 0.2 per unit. Okay, this is the J.2. I am drawing the positive sequence network, sir. Positive sequence network. Next, after transformer, what's our line? How much line reactance is given, sir? The line reactance is how much it is given? The transmission line reactance, sir. Line reactance. Positive is 0.2, sir. This is 0.2, sir. 0.2. Next, what it is given? There is a two transformers in parallel, sir. Two transformers in parallel. I am drawing the positive sequence networks. Positive sequence network. Yes. Our reference is the neutral line. Okay. This is how much, sir? J.3, sir. This is how much positive sequence networks of T2 and T3 transformer. This T2 and T3 transformer, all these reactances are same. It is given J.3. This also J.3. This is the positive sequence network. This is the positive sequence network. Okay, sir. You please concentrate. This is a positive sequence network. Now, what it is given? Yes, you want to find the Thevenin's equivalent impedance with respect to midpoint of a line, sir. This is the midpoint of a line. Let this is the x1 equivalent we are finding. Is it midpoint means this is how much, sir? This is 0.1. This side 0.1, sir. Yeah, this side also 0.1 because it's a 0.2 that is divided into 0.1 and 0.1. Now tell me, sir. Okay, this is total is how much, sir? This 0.25 is in parallel, sir. 0.25 in parallel means this is how much, sir? This equivalent is how much, sir? That is J.125. J.125. Okay, this is 0.1. This is 0.3, sir. This is J.2 means J.1 and J.1. Okay, this is J.2, J. This is total is how much, sir? J.3, sir. Understood? This J.3 in series with J.125. Here I am drawing this one. This is J.125, sir. The resultant I am writing. You please concentrate. Yes, sir. This is J.125. This is how much, sir? J.3. J.125 plus J.3, sir. How much? J.425, sir. This side J.425, sir. What about this side, sir? This is J.1. 0.3 in parallel, sir. Then resultant is how much, sir? J.3 by 2. That is J.15, sir. J.15, this is J.1, J.25. Then this is the resultant, sir. Okay, this you want to find resultant. This is J.425, sir. Okay, this is how much, sir? J.25, sir. This is J.25. This 0.425, here we are finding the x1 equivalents. Here we are finding the x1 equivalent. Then what is the x1 equivalent, sir? These two are parallel. 0.425 into 0.25 by 0.425 plus 0.25, sir. Then by simplifying this one, how much x1 equivalent we can get, sir? J.157 per unit, sir. 157 per unit. Very simple, sir. We are calculating the Thevenin's equivalent impedance. This is during calculation of Thevenin's impedance, sir. These are short circuited, sir. These sources are short circuited. Once it is short circuited, these two are parallel, sir. These two are parallel means, sir, how much, sir? J.125. This is J.125, sir. But this is J.1, J.2 is series, sir. J.3. J.3 plus J.125 is how much, sir? J.425. That means this side, left side of from the half of the midpoint of a line is J.425, sir. But the right side of the half of from the half of the midpoint of the line, sir, this is J.1, sir. These two are parallel. Two equal reactances are in parallel. J.15, sir. 0.1 plus 0.15 is how much, sir? 0.25, sir. This is 0.25. 0.25, 0.425 is parallel, sir. Then you calculate resultants are how much? J.157 per unit. Students, you please concentrate. Yes, this is about positive sequence reactance. Next, one more what it is asked. You want to find the zero sequence reactance. If you want to find the zero sequence reactance, now you can draw the what is the zero sequence network, students. But in drawing of zero sequence network, you please concentrate about the connections also. About the connections also. Yes. First I am drawing our reference is ground. In the case of zero sequence networks, our reference is ground, students. Our reference is ground. First I am drawing the G1. This G1 is grounded through some impedance. Yes, this is the G1. Yeah, this is grounded through some impedance. Yeah, this is how much, sir? For generator, what the zero sequence reactance? J 0.05. Yeah, this is how much, sir? This is 3 times of, this is 0 point. This xn equal to how much, sir? This xn is how much? It's not 0.25, sir. You please correct this. Point, this one. 0.05, sir. Xn is 0.05. You please also correct here. This is 0.05. Xn equal to 0.05 per unit. You please correct that. This 0. This x naught is also 0.05, sir. Xn also 0.05. But here what you want to substitute 3 Zn, sir. 3 Zn means how much? J 0.15. J 0.15. This is for generator 1, sir. What about generator 2, sir? Generator 2 is, yes, this is not grounded, sir. Isolated. Isolated means, sir, it is isolated from this ground. This is isolated. Okay, this is how much for generator 2 also, how much zero sequence reactance are? J 0.05, sir. But it is isolated. Next, which ones are? Transformer. This transformer primary sides are star with grounding. That is solidly grounded. Solidly grounded means line is closed, sir. Yeah, this is how much it is given, sir. For transformer, it is given J 0.2. You concentrate on T1 transformer, 0.2, sir. All the reactances are same. That you point to remember. J 0.2, sir. Here, separately is not mentioned positive, negative and 0. You take all these are equal. For total transformer, x1, x2, x0 equal to 0.2 only. Next, the secondary side also star with grounded, sir. That's why line is closed, sir. Line is closed. Then what about this line? Line zero sequence reactance, sir. This is 0.5, sir. Don't substitute 0.2, sir. This is a 0.5. Next, you please concentrate. Here from this point, this side star is grounded, sir. That's why it is connected. Then solidly grounded, sir. But this side is delta, sir. Delta means shunt switch is closed, but this side is, it is open, sir. Line is open. Line is open. What about this transformer, sir? This side is delta, sir. Line is open. This one. This side is delta, sir. Line is open. This line is, but shunt switch is closed. Then what about this, sir? The another side is grounded. Solidly grounded. That means here it is closed, sir. This line is closed. This line is closed. Because it is solidly grounded. Secondary side of T3 transformer is solidly grounded. Yeah, this is totally grounded. Okay, sir, this is total grounding. Okay, sir. Yeah, this is J 0.5, sir. What about this reactance, sir? J 0.3. For transformer, T2 transformer 0.3, sir. For T3 transformer also 0.3. Okay, this is the sequence network. You please concentrate. This side star with grounding, that's why it is closed. Delta is shunt switch is closed. Here delta, sir, shunt switch is closed. But this side star with grounding, it is closed, sir. Then you want to find midpoint from the midpoint of this one, sir. This is the midpoint. From the midpoint of this, you want to find the x0 equivalents. Okay, from the midpoint of this, you want to find the x0 equivalent. Yes, sir. Now tell me, from the midpoint of this one means, sir, this is how much, sir? J 0.25. This is J 0.25, sir. This side J 0.25. Yeah, this side also how much, sir? J 0.25. Because it is a midpoint. Now, this side, what is the reactance? This side, there is no current, sir, because it is open. The current will not flow like this. Current will not flow like this. This is J 0.25, J 0.45. This is how much, sir? This total is 0.2, sir. This total is point. This 0.05, 0.15. This total how much, sir? This is J 0.2, sir. J 0.2, here current will not flow like this. Current will not flow because ground is open. Ground is open. This is J.2, J.4, sir. 0.2 plus 0.2, 0.4. 0.4 plus 0.25, sir. Total is J.65, sir. This side, that half of the midpoint of left side of the transmission line is 0.65, sir. What about this side, sir? You please concentrate. This is J.25, sir. This is 0.3, sir. How much? 0.55, sir. But here current will not flow here. No need to consider this one. Current will flow through ground, sir. See, point students, don't confuse. If there is a line is connected and path is there for ground, then you take that impedance. If line is connected, path is there for ground. But here this you don't consider, sir. Why? This is the ground and this is also ground. Both are at same potential. There is no current here. But here this is the line, sir. This is the ground, sir. Then there is a potential difference. Then current will flow, sir. That's why you consider this one. Line and ground is there, yes, path. But both are at same potential. This is also at ground potential, sir. This is also at ground potential, sir. But it completely open, sir. How the current will flow? No need to consider this one. Then this is totally so much, sir. This series combination. 0.25 plus 0.3, sir. How much? J? 0.55, sir. Then resultant is this one, sir. Okay, this is the resultant. Okay. Here we are calculating the X naught equivalent, sir. X naught equivalent. This side how much, sir? J.65, sir. Please concentrate. This side is J.65. And this side how much, sir? J.25, sir. J.25. This 0.65, this is 0.25, sir. Then what is the resultant reactance? What is the resultant reactance, sir? That you write 0.65, J.65 in parallel with J.25, sir. Then if you calculate the resultant reactance, J.298 per unit you can. Yes, please concentrate. Here we don't consider this one because current will not flow because ground is disconnected. But current will flow like this. This reactance, this reactance, this reactance, half of this reactance is series, sir. 0.25, 0.45, 0.65, sir, total this side. This 0.25, 0.3 only series, sir. Half of this reactance and this reactance. But here don't consider this reactances, sir. But sir, here also open circuit, sir. Why you are considering? Yes, there is a path for ground, sir. Line ground is connected. Line ground is connected. There is a path, sir. You consider that one. Yes, is it okay, students? You please concentrate. How to calculate the X naught equivalent? See, any circuit is given. Whatever the single line diagram is given, you ready to answer. You ready to answer. You please concentrate. It's okay. Yes, for the following single line diagram, find equivalent zero sequence reactance with respect to A and with respect to B. Here, there is this I am giving for you, sir. This I am giving for practice purpose. I am giving for you. Yes, you draw the only zero sequence network. You find the only zero sequence, sir. You draw the zero sequence network of this one. You draw the zero sequence of network. And you find the what is the X with respect to A and with respect to B, sir. You find the what is the zero sequence network with respect to A and with respect to B, sir. This I am giving for practice for you. You practice that one. Then you can get with respect to A, sir. With respect to A, we can get Z naught equivalent equal to. I am giving the answers also. Please verify. Please check your knowledge, sir. Please check your knowledge. Then Z naught equivalent equal to. With respect to B, Z naught equivalent equal to, we can get J 0.017, sir. Sir. In per unit, I am giving. In per unit, J 0.044 per unit, sir. You try this one. With respect to B, sir. With respect to B, you can solve. This is A point, sir. This is the B point, sir. If you solve with respect to B, sir, then Z naught, only Z naught, sir. You can calculate. This Z naught equivalent, we can get J 0.046, sir. J 0.046 per unit. With respect to A, you calculate. With respect to B, also you calculate. Here I am giving that with respect to A, J 0.044 per unit. J 0.046 per unit, sir. 46 per unit. Z naught equivalent. Students, you please try this one. You check your knowledge. Are you understood or not? This sequence component networks. Okay, once you are solved this one means yes, you are 100% confidence in this sequence networks and symmetrical components. Sir, this is about what exactly most expected questions for GATE and ESE and PSUs point of view. Students, follow me on Unacademy using this link for more updates about my videos. Okay. Okay, this is our Unacademy GATE Telugu Telegram channel. You register this one. Whatever the concepts we are applying, whatever the concepts we are explaining, all those concepts, that material we are uploading as a PDF material in this Telegram channel. Then you can freely download all these materials for reference purpose. These are India's #1 study channels, that is Creatics GATE, EE, EC and Instrumentation, Unacademy GATE Mechanical Engineering, Unacademy GATE Civil Engineering, Unacademy GATE Telugu, Unacademy SSC JE, Unacademy Computer Science, Unacademy GATE Questions, Electrical Junction, Engineering Padishala, GS Terminal, RRB and SSC. These are India's #1 study channel, students. You please concentrate all these. Okay, thank you, students. In the next coming session, we'll start with this. 2 chapters are completed. Current system analysis chapter is completed. Symmetrical component chapter is also completed. The new chapter I'm starting next class onwards, next session onwards, that is fault analysis. Students, very important concept. Be ready for whatever the GATE questions you can want to solve on fault analysis. Please follow my video on the fault analysis. Then whatever the GATE questions are there, whatever ESC and PSU questions, then what questions we can expect, all these questions we can solve. No doubt at all. Yes, you please concentrate. Okay, thank you, students.
It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
Where you put your knowledge to test.
and battle it out with the best.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
With detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat.